Today, let us talk about thermodynamics. Thermodynamics is the branch of engineering and physics in which we learn heat, work, temperature, and energy. If we do not have proper knowledge and concept in thermodynamics, then we cannot go ahead in further study of mechanical engineering. This thermodynamics is the basic of mechanical engineering. This is a very important subject, and there are many important topics in thermodynamics. Some of the important topics are thermodynamic state, thermodynamic properties, cycles, vapor power cycles, gas power cycles, refrigeration cycles, first law of thermodynamics, second law of thermodynamics, entropy, enthalpy, internal energy, flow process, non-flow process, available energy, non-available energy, irreversibility, availability, etc. Today I will discuss the topic the vapor power cycle and gas power cycle, and this class will be a comparative study on this particular two power cycles. Hello everyone, I am Professor Deepak and do welcome you all to my channel. So before the start, subscribe my channel to get more videos. So this vapor power cycle and gas power cycle, they both are power cycle. Okay, so these cycles are used to produce the work. Okay, so from this kind of cycle we get power, or we get energy. So today I will compare this vapor power cycle and gas power cycle. Vapor power cycle, power cycle, and gas power cycle. Okay, so today I will teach the vapor power cycle and gas power cycle. Okay, so we'll have a comparative study so that we can understand what are the basics of these power cycles and how these two power cycles are different. Okay, although the both cycles are power cycle which are used to produce power or energy, but there are some differences. Okay, so today we will learn the differences. So first one is vapor power cycle, and next one is gas power cycle. Okay, so both are power cycle, but only difference is in the name, vapor and gas. Okay, so due to the different working substance, okay, in this power cycle the working substance is vapor. Okay, so in our power cycles we have the working substance gas, mainly gas or air. Okay, so we will compare these two cycles, okay, in different respects. Okay, so the first point on which we will have a comparison between these two cycles is first one, working substance. So first we will write working substance. Working substance. Okay, so first one is on the basis of working substance. Clear? So in the vapor power cycle, the working substance or working fluid is vapor. Okay, it may be vapor, it may be water. Okay, so as per the working substances, these two power cycles are different. Okay, so in the vapor power cycle we have working substance as vapor and liquid, mainly water. Okay, mainly water. So in the vapor power cycle we have the working substance is either vapor or liquid. Okay, so inside the vapor power cycle there will be the working substance which is having vapor and liquid condition. Okay, so here we have different phases of working substance. So in the vapor power cycle we have different phases of working substance, but in this gas power cycle we have the working substance is air or gas. Okay, so here the working substance is gas or air. Clear? So in the first respect, these two power cycles are different because their working substance are different. Okay, here the working substance is vapor and liquid, and here the working substance is either gas or air. Okay, so here we have only single phase of working substance, but in the vapor power cycle we have different phases of working substance. Okay, so in some points of this power cycle the working substance will be liquid. At some points of cycle there will be vapor condition of the working substance. So in this process, so in this power cycle we have different phase. Okay, different phase of working substance. So in this vapor power cycle, the first point is it will have a different phase of working substances. Okay, so phase change will occur in this particular power cycle, but in the gas power cycle there will be single phase of working substance. It will be either gas, it will be air. There will be no liquid phase of the working substance. So here we have a single phase. Okay, so the next difference between these two power cycles are about the machine component. Okay, so there are different structures of the machineries. Okay, so in vapor power cycle there is different structure of the machine, and here the machine has its different structure. So first, the second point is number 2. It is machine components are boiler, turbine, condenser, pump. So these are typical parts. Okay, so this boiler, turbine, condenser, pump, these are typical parts of the power cycles. Okay, vapor power cycle. But in case the gas power cycle, normally what happens, normally we have a single machine, a reciprocating engine, reciprocating engine. Okay, so in the second case we have found the difference between its structure. In this gas power cycle the main machine is single machine, which is reciprocating engine. Okay, so a reciprocating engine where cylinder, piston and connecting rods are there. So by the single arrangement these power cycles can be conducted. Okay, but in case of vapor power cycle, to have the cycle completed, okay, we need different parts of machine. So for example, here typically we need boiler, turbine, condenser and pump. This comparison is very interesting because we simply understand for the vapor power cycle we need different machines to have the cycle completed, but here the single machine is enough to get the complete gas power cycle. Okay, so in this gas power cycle it may be reciprocating engine, and in addition to that there may be some other single engine like rotary turbo engine. Okay, So these are normally single machine cycle, and this is actually a cycle which is completed by different kinds of machine component. And in the gas power cycle we have another example, which is gas turbine. Okay, gas turbine cycle. Okay, so here we have different parts of machine, but that one is also like single arrangement. So in the gas power cycle we have third example, gas turbine cycle, which is having different parts of engine. Okay, but in the single arrangement the components are connected, and in the gas turbine cycle the complete gas power cycle is carried out. And the third difference between these two cycles are the combustion process. Okay, so in the gas power cycle we have internal combustion. Okay, but in case of vapor power cycle we have a external combustion. Okay, so this one is third, this is external combustion. External combustion. So here it is internal combustion. So the third difference is the combustion process. So here the combustion process is internal, but here the combustion process is external. So what does it mean by the external one? So here the combustion will take place in external device. So here the boiler will be there. So inside the boiler combustion will take place, and due to the combustion the working substance will change its phase. It will convert from liquid to vapor. Okay, so in this way working substance will be converted. Okay, but the combustion process will take place externally. Okay, so this is the case for the vapor power cycle. And for the gas power cycle it will be internal combustion. Internal combustion means the combustion will take place internally. Okay, so take the example of this reciprocating engine. So in reciprocating engine, in the same engine the combustion will take place. Okay, so in this gas vapor cycle the combustion will take place internally. That means the combustion will take place in the internal way. Okay, so take the example of reciprocating engine. So in the reciprocating engine we have a single arrangement of cylinder and connecting rod, piston, etc. So inside the cylinder itself the combustion will take place. This is the very important difference between this vapor power cycle and gas power cycle, because their combustion is externally done and here the combustion will take place internally. Okay, this is the third comparison. Okay, so let us move to the fourth comparison, where we find how these power cycles are different. Okay, so here we need to have our different page. Okay, so we have here vapor power cycle, and here we have gas power cycle. Okay, so the fourth comparison is on the basis of process. Okay, so in this vapor power cycle, since different machine components are connected to get the complete cycle, so the processes are flow process. Okay, so here the processes are flow process. Okay, so in this case the processes are flow processes. Okay, flow processes means the working substance will flow continuously from one part to another part. Okay, so along all the major components, the working substance will move and flow. Okay, that's why this will be called flow processes. It will be non-flow process. Okay, so the fourth difference is non-flow process. So whatever processes will take place for a gas power cycle, those processes will be a non-flow process. Non-flow process because the processes are taking place inside the one arrangement. Okay. So to understand this flow process and non-flow process, let us draw some figure so that we can understand how this flow process and non-flow processes are taking place inside these power cycles. By using all the important machine component, the flow process will take place, and after that, the vapor power cycle will be carried out. So piston will move in such a way that all four processes will take place, and after all the non-flow process will happen, and as a result vapor power cycle will be completed. So here we have a single arrangement of a machine. That side we have different machine components which are connected to get the complete cycle. So I believe that you have already understood the basics of vapor power cycle and gas power cycle. You have realized how these two cycles are different. You have understood what are the basic differences between these two cycles. Thank you so much. See you in the next class.